Hey everyone, and welcome to The Explainer. Every single day, we hear about new security breaches, new software bugs. It's a constant flood of information. But how did the pros actually make sense of it all? How do they decide what to fix first? Well, today, we're pulling back the curtain on the system they use, the Common Vulnerability Scoring System, or CVSS.
Okay, let's just dive right in. Picture this, you're in charge of security for a company. Your dashboard is lit up with alerts for hundreds, maybe thousands of new vulnerabilities. Some are kind of minor, others could be absolutely catastrophic. You can't fix them all at once, so where do you even begin? That massive prioritization problem is the exact reason CVSS exists.
And here it is, the industry's answer. Think of CVSS as a universal language for security risks. It's an open, standardized framework that lets a developer in one country, a security analyst in another, and an executive across the globe all talk about the exact same vulnerability using the same objective rules. It's all about replacing gut feelings with a structured, consistent conversation.
So, to really get a handle on this language, we're going to break it down. We'll start with the three big score groups. Then we'll look at how each one builds on the last. From the vulnerability's permanent DNA to its real-world threat level right now, and finally how it actually applies specifically to you. Okay, first things first, and this is really important. A CVSS score isn't just one single number. It's actually a combination of three different groups of metrics. You can think of them as layers of context, where each new layer gives you a clearer, more specific picture of the actual risk. And honestly, this analogy just nails it. The base score, that's like your car's official crash test rating. It's baked into the car's design. It doesn't change. The threat score, that's your GPS screaming at you about a sudden hailstorm or a huge accident right on your road. And the environmental score? Well, that's you, thinking about the fact that you're driving that specific car at night in that hailstorm with your family in the back. See? Same car, totally different risk. All right, so let's dig into that foundation, the base score. This number represents the permanent, unchanging qualities of a vulnerability. It's figured out by the researcher who found it, and it stays the same for everyone, everywhere, forever. It's like the vulnerability's DNA.
So the base score itself really answers two big questions. Over on the left, you've got the exploitability metrics. This is basically, how hard is it for a hacker to actually pull this off? And on the right, you have the impact metrics. That's the so what? If the attack works, how bad is the damage going to be to your system's confidentiality, integrity, and availability?
Let's break one of those down. Attack vector. This is all about proximity. Does an attacker need to physically touch the machine? Or do they just need to be on the same Wi-Fi network? Or can they do it from halfway across the world over the internet? It's pretty simple. The further away they can be, the higher the risk and the higher the score. Now, attack complexity. This one's really interesting. This isn't about how smart the hacker is, it's about the roadblocks the system itself puts in their way. A low complexity attack is one that just works, plain and simple. A high complexity attack means the attacker has to get lucky, maybe win a race condition or deal with some weird specific security setting that's out of their control. And all of these little details get recorded in something called a vector string. Now, it looks like a line of code, I know, but it's really just a standardized shorthand. So here, AV.N means attack vector is network. AC.L means attack complexity is low. It's a super fast way to see the whole story of the base score in one glance. Okay, so the base score is a great starting point, but it kind of exists in a perfect theoretical world. The real world, though, it's messy, it's dynamic. And that's exactly where the threat score comes in. It adds that crucial real-time context about what's happening out there in the wild. And this really all boils down to one key thing. Exploit maturity. This metric answers the most urgent question of all. Has somebody actually written code to exploit this thing? Is there a simple proof of concept floating around, a fully weaponized tool, or worst case scenario, are hackers already out there using it? Because a vulnerability that's being actively exploited is a whole different level of danger. And just like we saw before, this new piece of the puzzle gets added to our vector string. In this case, that EA tells us that the exploit code is attacked. It's being actively used in the wild. That one little letter can completely change how you prioritize things. And that brings us to the final, and maybe the most personal layer, the environmental score. The base and threat scores are the same for everybody. But this is where you get to customize the score to fit your specific reality. And honestly, it might just be the most important step in the whole process. This is where you answer the real-world questions that only you can. Like, do you have some other security tool, like a firewall, that already stops this kind of attack? And how important is the vulnerable system? Is it just a test server in a lab? Or is it the database with all your customer data? A critical vulnerability on a junk machine might be a low priority, but a medium one on your payment server, well, that's a 5-alarm fire.
So we have the base score, the threat score, and the environmental score. How does all this come together to actually help a security team decide what to do next? Well, it's a really clear, logical flow. First, the software vendor gives everyone that unchanging base score. Then, your security team layers on the threat score based on what they're seeing hackers do right now. And finally, you apply your unique environmental score. The final result isn't just a random number. It's a contextual, defensible decision about exactly what needs to get patched first. And this quote really gets to the heart of it. The whole point of the system is to remove emotion and subjective gut feelings. Because the framework is standard, 2 different analysts in 2 different companies should look at the same vulnerability and come up with the exact same base score. It creates a common ground for objective, repeatable risk assessment for the entire industry. So let's end with this thought. A vulnerability with a critical 9.8 base score is obviously a big deal. But what about one with a low score? If that low-risk vulnerability is on your company's most critical asset, and you find out that hackers are starting to actively exploit it, well, that low score might just become your #1 problem. With CVSS, as with all of security, context is everything.